Welcome back in Arnav's online chemistry classes. In today's class, we are going to explain about another very interesting topic of coordination chemistry, that is Werner's coordination theory. Werner's coordination theory was given by Werner in the year 1893 and he was awarded by Nobel Prize in 1913 for his wonderful work to explain the structure and bonding in coordination complexes. Now, in this particular unit, I am going to explain you not in theoretical way but in more practical way by taking an example to explain the Werner's coordination theory. The main point of Werner's coordination theory that coordination complexes shows two types of valencies. The first one is primary valency. Primary valency, and second one is secondary valency, which means any coordination complexes have two types of valencies, one of which is called primary valency and the other one is secondary valency. Now, you would like to know that how one can identify that which one is primary valency and which one is secondary valency. Negatively charged ion all the negatively charged ion present in the given complex known as primary valency, and secondary valency, number of ligands attached with the central atom, or rather you can say that the number of donor sites of ligand attached with the central atom. Primary valency gives the idea about the oxidation state of central metal atom, whereas secondary valency gives the idea about structure of the coordination complexes. Secondary valency provides the idea about structure of the coordination complexes, and primary valency is represented by the dotted line, and it is non-directional. In any direction around the central metal atom, we can put the second primary valency, whereas secondary valency represented by the solid line, and it is directional. Since it is directional, it provides the idea about the geometry of the complexes. And one thing that is also a very important point I will give, and that is sometimes primary valency or the negatively charged ion satisfying both primary and secondary valency. The negatively charged ion which are satisfying secondary valency always kept inside the coordination sphere, and which are not satisfying the secondary valency must return outside of the coordination sphere, which means secondary valency always kept inside coordination sphere and primary valency satisfying the ion always written in the outside of the coordination sphere. So we have discussed some very vital points of Werner's coordination theory in short form. Now we have to understand that how these principles are operating, and for that we have to take an example which was taken by Werner. Werner mainly studied the complexes of cobalt and platinum chlorides having octahedral geometry. This can be illustrated by this particular example, COCl3.6NH3, and this is